Okay, we'll start with question 58. So it says that I have glucose and I ferment it to produce ethanol and carbon dioxide. The key here to do any of these questions, these stoichiometry questions, you always have to start with a balanced chemical equation. If they haven't given you an equation, you need to write one. The second thing that you have to do is just make sure that it has been balanced and you have the appropriate coefficients. Now, you're lucky. They went ahead and gave you that equation. You don't have to do a whole lot of work here. That's done for you. Most likely on the AP exam, they'll do the same thing. They'll go ahead and give you the equation. It's going to be balanced, and they're going to ask questions off of that. All right, so if you look at parts A, B, and C, and I'll do all three parts, each one of these parts, you only have one given. They only give you one value. Anytime that you only have one value in the actual prompt, that's an indication that what you're dealing with is what I call an ideal stoichiometry question. So ideal stoichiometry is ideal because the calculations are very minimal. You only have to do one fence post for these things. What ideal stoichiometry really means is that they're flat out telling you the substance that runs out first. You assume everything else is an unlimited supply. And it's ideal because you don't have to do that detective work of figuring out who the limiting reactant is first. They flat out are telling you, in this particular case, it's the C6H12O6, because that's the only number that they've given you. All right? All right, so first thing that I do is I write my equation on my paper. And then I make a little inventory underneath the reaction of what they give me and what they want. All right? So in this particular case, they tell me that I'm starting with 0.400 moles of glucose. And they want me to calculate moles of carbon dioxide. So they're giving me values for one substance, and they want me to change it to values of another substance. All right, well, first thing I ask myself, is the given that they've handed me, is it in a unit that I like? The answer is yes. What's the unit that I love the most? The mole. They gave it to me in mole. Fabulous. I'm going to draw my fence post. I'm going to write that value in the upper left-hand corner. And here, I'm going to caution you one more time. It's really critical that in each of these boxes you write number, unit, substance. If you don't write the substances that those numbers are tied to, you're going to get lost really quickly and get the wrong answer. Don't be afraid to use up paper. Don't be afraid to waste lead. Number, unit, substance in each box. All right, so the other thing that I do is over on the far right, I go ahead and I jot down what they want me to change that value to. So they want me to convert it to moles of what? CO2. So I write moles of CO2 on the far right just to remind me about what my goal is. All right, well, the beauty of having that given in moles is that it gives me permission to use a conversion factor in here called the mole ratio. And the mole ratio comes from that balanced chemical equation. It comes from the coefficients. All right? Remember when we were learning how to do conversions from mole to particle? And I was kind of showing you how to lay down the units and how to do dimensional analysis? Let's do that. Okay? So what unit would you put down here? This is kind of a no-brainer. Moles of C6H12O6, moles of glucose. Why would I put that unit in that denominator? Because you want them to cancel out? I'm going to put moles of CO2 on top. All right? Now, the numbers that go here come from the coefficients in that balanced chemical equation. So what's the coefficient in front of CO2 in that equation? 2. What's the coefficient in front of the glucose? 1. All right? Is the unit that's left uncrossed the one that I want for the answer? Yeah, so I'm done. So all I need to do is do 0.4 times 2 divided by 1. And the answer has to be rounded to 3 significant figures because my given was to 3 significant figures. So we don't even have to grab the calculator, right? Because what's 0.4 times 2? To 3 significant figures, you would write 0.800 moles of CO2. All right? So that's how you do part A. Let's do B. Let's go back and read B. How many grams of C6H12O6 are needed to form 7.50 grams of C2H5OH? All right, so once again, I'm going to write the equation again. And I'm going to make a quick little inventory about the information that they gave me here. So I've got, I want to make 7.50 grams of the ethanol. They want to know how many grams of glucose are necessary to do that. So this is the end target. That's how much they want to make. They want to figure out how much of the ingredients you need to purchase or to ferment to get that end target. All right, so I write 7.50 grams of C2H5OH in the upper left-hand corner. I want to change that number to grams of C6H12O6. Look at that given. Is that a unit that I'm happy with? Yeah. No, I absolutely loathe it. I would rather see that written as mole. So let's convert it to mole. So 1 mole of C2H5OH, well, how much does that weigh? I don't know, but I can figure that out pretty quickly. How do I figure that out? Add what? The molar mass. So 2 times the mass of carbon off the periodic table plus 6 times the mass of water plus 1 oxygen, right? So the molar mass of this is 46.08 grams. Grams cancels out with grams. All right, now that I'm in moles, what am I allowed to use? Mole ratio. Fabulous. So what would the unit be for the mole ratio in the bottom? It'd be 2 moles of C2H5OH. What would the numerator read? It would be 1 mole of C6H12O6. Moles of ethanol cancel out with moles of ethanol. Now, did they want me to stop at the mole of glucose? What did they want the answer in? So how do you go back to grams? You multiply by what? The molar mass, because 1 mole of C6H12O6 weighs how much? It's like 180. Let me see. $180.18 grams. All right, so moles cancels out with moles. What you do with your calculator is you do the product of the numerator and then you divide it by the product of the denominator. So I'm going to do, in my calculator, I'm going to type in parenthesis 7.50 times 180.18. I'm going to close the parenthesis and I'm going to divide by, and I'm going to open a second set of parentheses, 46.08 times 2, close the parenthesis. The answer that you get should be rounded to 3 significant figures like you're given. So I'm going to write 14.7 grams of glucose. Okay? Yes, Emma?
I got a different answer.
What'd you get?
I got like 58.
58 for what? For the final answer?
Can you explain how to enter in the calculator?
What kind of calculator are you using? A TI-84? Can you loan me yours? Because mine's like deep in my bag. Can you see the screen okay? Okay. Parenthesis, 7.50 times 180.18, close the parenthesis. So those are all the numbers that were in the numerators. All right? And then I'm going to do divide by, and then I'm going to open a second set of parentheses, not cosine, second set of parentheses. And I'm going to put the numbers that were in the denominator. So 46.08 times 2, close the parenthesis. You see that? 14.7. Try it one more time. Or, you know what, can you pull up your, I guess you can't pull up your last entry to see what the difference is. Well, she can't now that I've typed into it. All right, let's take a look at C. C is a very similar question, except for in part C, instead of being asked about the glucose, they're asking me about the carbon dioxide with the same end goal, to make 7.50 grams of ethanol. So the fence post is going to look very similar. You're going to start with 7.50 grams of C2H5OH. You're going to realize that that's not a unit that you want to see at the beginning of that fence post, so you want to change that to moles first. The difference is, instead of converting to grams of glucose, you're going to convert to grams of CO2. You're looking for a different endpoint for this problem. All right, so the first thing I'm going to do is convert to mole. It's the same molar mass that we calculated in part B. Where things are going to change now is in the mole ratio. The mole ratio, the denominator is going to look the same as the prior fence post. The numerator is what's going to be different, because instead of going to glucose, we're going to go to carbon dioxide. There's 2 moles of CO2 instead. All right, and then in the final step, I didn't want my answer in moles, I really wanted it in grams, so I'm going to have to convert back to grams. I know 1 mole of CO2 has a mass of 44.01 grams. Mole cancels out with mole. So on my calculator, I do 7.50 times 2 times 44.01 divided by 46.08 divided by 2. I'm going to round my answer to 2 significant figures. I get 7.16. Is that right? Okay. In a little bit, Emma, when you start working, I'm going to look over your shoulder and see how you're typing things in. Okay? All right. So that was question number 58. And you were assigned 57. It's very similar, just a different equation. All right? Let me do question number 60. And then you guys go back and do 59. All right, so question number 60 tells me that you have an iron ore sample. It contains iron 3 oxide together with other substances. The reaction of the ore with carbon monoxide produces iron and carbon dioxide. First thing that they tell you to do is balance the equation. The second thing that they tell you to do here, well, you can't even see that, is to calculate the number of grams of carbon monoxide that can react with 1.50 kilograms of Fe2O3. And then C, they ask you to balance the number of grams of Fe and the number of grams of CO2 formed when 0.150 kilograms of Fe2O3 reacts. So part C is kind of tricky. It's actually 2 questions in one. All right? Let's start with H, is the balancing bit. So Fe2O3, I know it's off camera, I'll move my hand in a minute. All right, so this is the equation that we're dealing with. Is that contrast better? Yeah, it's easier to read. All right, what should we balance first? How do we balance this? I would start with the oxygens. How many oxygens do you see here? Would you? I don't know. Maybe the oxygens aren't the best. Carbon? Carbon's balanced already. I wouldn't do iron first. I think oxygen, we have no choice but to do the oxygens. We have 4 oxygens on the left, but 2 on the right. Which means that I would have to put a 2 in front, right? Well, that's a problem. Because then I would have to put a 2 over here. And now I'm back to having an odd number of oxygens on the left-hand side. So how do you fix that now? Remember, one of the rules for balancing, always make sure that you have evens on both sides. What if I put a 2 over here? Is that going to help my case out any? Where? On the CO2? to give me 6, and put a 3 in front of the CO. Hey, that's a nice solution. Because now that gives me 6 oxygens and 3 carbons. And then I just need to fix the iron by putting a 2 in front. Nice. All right. Part B tells me that I have 0.150 kilograms of Fe2O3. They want me to convert that to grams of carbon monoxide. All right, so this is very similar to what we did before. The only difference is that we're going to have to add an extra piece to the fence post because they're giving me my starting value in kilograms. Do I like kilograms? Do my scales read in kilograms? My scales would prefer to read in what? Grams. So you first want to change it to grams because then when you use the molar mass is in grams. You want consistent units. So you know that for every 1 kilogram, there's 1,000 grams. And so now you're in grams of Fe2O3. You put the substance there. All right. At this stage, you should recognize grams is no good. I have to change that to mole. So 1 mole of Fe2O3, that's heavy. How heavy is it? 2 times the mass of iron. What's iron? 55.85? Plus 3 oxygens. It's 159.7 grams. Fe2O3. At this stage, you go to the mole ratio. For every 1 mole of Fe2O3, you are going to make 3 moles of carbon monoxide. That cancels out. And then they didn't want the answer in moles. They really wanted it in grams. So you got to convert back to grams. 1 mole of carbon monoxide weighs 28.01 grams. All right, so mole cancels out with mole. And so now I just have to do 0.150 times 1,000 times 3 times 28.01, close the parenthesis, divided by 159.7. Whatever the calculator spits out, you round to 3 significant figures like the given. So this is going to be 78.9 grams of carbon monoxide. All right. All right, so part C is pretty much the same thing, except for part C, they're sneaky in the way that they wrote this question. I don't know if you can see it from here. Because in part C, they want you to calculate the number of grams of iron and the number of grams of CO2. So you're going to have to do 2 separate calculations, both of them starting with 0.150 kilograms of Fe2O3, but one of them converting that number to grams of Fe, the second calculation converting it to grams of CO2. It's 2 separate questions, but they wrote it as one. No. They're 2 separate fence posts. You don't add the answers because they're talking about different compounds. It's like if I ask you, I want to bake 20 cakes, and you have a recipe at home, and I ask you, how much flour do you need, how much sugar do you need? You would do one calculation to figure out how much flour you need. You do a second calculation to figure out how much sugar you need. You don't add those amounts at the end, right? Because you need to know individually how much. That's basically what they're asking you. Okay? All right. So 60 is very much like 59. Actually, 59, what I assigned you is easier because they gave it to you in grams, not kilograms, so you don't have to do that extra piece in the middle. But just know that it's just a matter of putting just an extra bit on the fence post to let you convert to grams. All right, well, let's see. Then the next thing I assigned you was question 61. It's a lot of the same thing. It's the same kind of math. All right, so again, they ask how many grams of aluminum hydroxide are obtained from 14.2 grams of aluminum sulfide. You only have one numerical value in that prompt that leads you to the path of a limiting reaction question, But the issue here with question 61 is, what have they not given you here in this word problem? What's missing? The balanced equation. And so I think rather than doing 62 for you, why don't I just help you write the equation for 61? Yes, Andrew? Say what? Technically ionic. H2S. If it was covalent, you'd call it hydrogen dihydrogen monosulfide. Okay? All right, so I don't want to do 62 because I don't want to keep bothering you. I'd rather give you time to do your own problems, like with the same kind of calculation over and over and over again. But I'm just going to help you 61 write the equation. So for question 61, they tell you that you have aluminum sulfide. So what's the formula for aluminum sulfide? Well, aluminum's 3+, sulfur is 2-, so what, crisscross, what do you end up with? Al2S3. Okay. So Al2S3. It reacts with water to yield aluminum hydroxide. Well, aluminum's 3+, hydroxide is OH1-, so what's aluminum hydroxide? Al parentheses OH parentheses 3. And hydrogen sulfide. Hydrogen sulfide is hydrogen H1 plus and S2 - coming together. What would that be? H2S plus H2S. For stoichiometry purposes, you write equations in general form, not net ionic form. Okay? Is this equation correct as written? No, what's missing? Gotta need some coefficients, right? There's 3 sulfurs there. I need to get 3 on the right-hand side. There's 2 aluminums there. I need another 2 aluminum on the right-hand side. And now if you notice, there are 6 hydrogens plus another 6. That's a total of 12 hydrogens. So I'm going to put a 6 in front of the H2O to correct that issue. And by putting the 6, now that gives me 6 oxygens. And I have 6 oxygens on the right. Now that balances out. You cannot do any of this math if you don't have a balanced chemical equation. So that's the first thing that you have to master. Okay? Yes, Andrew? Okay, so say for instance, you do all the fence posts and, like what question are you asking me about? 60D? 59D? Okay. Well, so basically you would calculate, or you might be given this value. And you would be given this value. Right? Or maybe you are given that value, maybe you're not. Maybe you're asked to calculate it. Okay? Maybe somewhere else in the word problem, in the prior parts before, they ask you to calculate that value. And maybe another piece of that problem asks you to calculate that value. Once you have all these values calculated, you want to show that x plus y equals a plus b. You want to take the actual numerical answers that you got out of your fence posts and show that the masses of the reactants equal the masses of the products. That's all they're asking when they ask you in these questions, to show that your calculations are consistent with the law of conservation of mass. That's all they're asking. For you to do just a double check on the final n. And that's it. So you take your, the givens that they, so once you do all your fence posts, say the fence post asks you to solve for this thing. So part A asks you to solve for that thing. Part B asks you to solve for this thing. Part C asks you to solve for this thing. Part D then asks you, for question number 59, even for 60, it says, show that your calculations are consistent with the law of conservation of mass. The way that you do that is you just add the masses of the 2 reactants together and show that it equals the masses of the 2 products together. Okay? And that's just a cheap little way for you to double check that your math is good. Okay? I would always do that to check my work. All right. If they're not equal, then there's a problem with one of the fence posts. And 9 times out of 10, the issues with people's fence posts are their molar masses. Is that the door? No, I thought it was.
Yep. Oh, it is.
It is a D. Yeah. All right. One more. Ask me.
So I'll make the
And now you want to like aliquot out the other ones.
No.
You might want to dump it back in and mix it because it needs to.
Yeah. I can. Can you dump it back in?
Just cut the stems, dump it back in, mix it, and then re-aliquot it. Thank you. Do you need the key?
Yeah.
All right. Okay, last question. I assigned question 63. Ooh, it's got something in there about density. Fun. Let me do 64. No, I don't want to do that. Nah, you know what? You do 63 on your own. See if you can figure it out. Worst case scenario, tomorrow when I'm going over homework, we can do that piece. Okay? All right, so I'm going to call it quits here.